Welcome to the Applications Manager free training series. Let's get started. Bridging the visibility gaps in your multi-cloud infrastructure. The agenda is as follows. We will start with proactively monitoring your AWS and Azure cloud infrastructure, which means how to discover the AWS and Azure. Once it is discovered, how would you track the performance metrics? What is the health status of the EC2 instances deployed, or what is the health status of Azure VMs deployed on cloud, private cloud, or public cloud? And once the cloud infrastructure system is discussed, then the second topic for today will be tracking the critical key performance indicators of your container orchestration platform, which includes Docker containers. We'll start with Docker containers, and then we'll move to Kubernetes discovery and OpenShift. And the third topic will be pinpointing the performance bottlenecks in your cloud environment by setting a right threshold profile in an automated using an AI ops based approach to filter the unwanted alerts and reduce the incident volumes, focus on prioritized alarms. And the final topic will be keeping a tab on the performance of your Microsoft applications. So let's start with the 7 R's of cloud application modernization. Whenever you migrate your workloads, application workload to the cloud, basically 7 R's to be considered whenever it is shifted from mainframe to physical machines and then monolithic application to a service-oriented architecture. People say whenever an application modernization occurs, major things to be considered are as follows. Someone say that they wanted to modernize an application for the cloud. So what exactly do they mean? So every users have their own perspective, right? So for example, a workflow application, say let's assume it's a healthcare application used by dozens of users written in the latest versions of Java with the combined database used by would be MySQL. So it might be an easy lift and shift to the cloud, which requires very little code rewriting. But assume a situation if there is a similar kind of application which is written on COBOL or C++ and runs on mainframe, there's a good chance that this application should be retired or should put in overhaul before migrating to the cloud. So retiring the apps that are no longer valuable is one of the important aspect when we consider the application modernization, which is a part of your organization strategy. And replacing the apps with the open source components. When we say replacing the apps with the open source components, let's assume that you have proprietary solutions which are no longer necessary, then replacing a similar kind of application with the third party services or replacing a similar application with an open source systems like Kubernetes. Okay. So this will definitely help the enterprise IT organizations as a part of the modernization. The third aspect, relocating the app to the cloud, as the name itself suggests, application which requires high demanding business requirements, which is hosted on top of and supportable software systems, is easy for relocating, right? So previously what we do, we dedicate a specific physical machine or hardware which requires the IT teams to invest on that specific. It is easier to configure or move these kind of workloads to cloud. It's in a similar way that you could configure dev, test environments, auto scale, or in fact, DR systems in a very easy scale. And in fact, re-platforming the components which have operational benefits. When we say re-platform the components which have operational benefits, instead of completely shifting your entire application portfolio, you could reuse a similar kind of design, pattern, services, APIs to rebuild the similar application, which definitely useful in terms of modernization. So now let's see how do we achieve all these application modernization using ManageEngine Applications Manager. The first step hosting the load on cloud. What load? Application workload is what we'll discuss. So why we shift to the cloud? So before we talk about the load and monitoring, let's understand why companies have shifted to cloud because of the flexibility it offers. So if I say flexibility, what does it mean? So you have multiple, the users or the IT teams have multiple options to go with. There are various vendors available, AWS, Azure, GCP. Depending upon your application portfolio, you could choose the services and the commercials. It's again possible because all majority of the cloud vendors provide pay as you go model, which is based upon the workload that you're hosting, you will be billed. And security on top of cloud, companies have were focusing more towards the security approach and which is highly controllable using the various resource group policies like VPC and network security groups. So the network admins or the application admins have complete control over all these parameters, and the storage extend or reduce it is possible. So considering all these benefits, companies have shifted to the cloud. Now let's talk about the challenges faced when we modernize your applications or shift your application workload to multiple cloud, or if you already have an cloud-based workloads, what are all the challenges that you are facing, right? So most of you would have noticed this: server crash, unnecessary server crash, CPU memory spike, and you want to understand why the CPU memory disk spike is occurring. Unexpected downtime because of a server crash, slow application, user complaint. Optimizing the application is a challenge, okay? Because your application is not a single entity. It talks with multiple components. If I say multiple components, application talks with the database, application talks with the API, application talks with the microservices-based systems. How do you connect these dots to understand your application workflow? So for that, understanding the dependencies is required. If there is a latency between two containers, as a result, the login service will be affected. So these kind of logical mapping between the underlying infrastructure should be created. So now, as a first step, how do we monitor cloud apps or containers in Applications Manager? To start with, ManageEngine Application Manager is an agentless on-premise monitoring solution. So if I say agentless, it doesn't require you to deploy any agents on EC2 instances or in any cloud platform. It is going to be a plug and play monitoring. And how does this plug and play monitoring works? From the tool, we hit the CloudWatch APIs for Amazon, for Azure. We hit the specific metric aggregator, that is the data collection happen via API, and similarly for GCP and for Oracle Cloud. So the data collection happens via an REST API and through other JDKs as well. So no agent is deployed, which means there is no load to the end resources, to the end target machines, to the end load. You can safe and securely ensure that your resources were being monitored, and all those monitored data will be present inside your on-premise data center or inside a specific data center which you allocate. And that could be, in fact, in a cloud-based system. So you can, in fact, deploy the tool on Azure Virtual Machine or in an Amazon EC2 instances as well. So now let's talk about the list of supported technologies that we offer. So it starts with Amazon Web Services, Microsoft Azure, Google Cloud, Dockers, and OpenShift, and most importantly, Kubernetes. So when we say, when you modernize these applications from monolithic to a microservices environment like Kubernetes or containers, these app modernization are not free of cost or risk. For organization with thousands of application, it can in fact take years to fully modernize your entire application portfolio. So the DevOps teams and architects must use your lens of practicality to review all the factors before selecting your application modernization strategy. So now let's start with the proactively monitor your AWS and Azure infrastructure. So to collect the Amazon Web Services information, what we do, we hit the CloudWatch API and a specific IAM user ID and key is required. And basically, you could provide administrative a user with administrative privileges. If in case if there is any security restrictions for administrative privileges, then that specific user should have access to these APIs like describe instances, describe volumes, list buckets, list tables. If using these API permissions, we will be able to get the performance metrics of all these components deployed on AWS and show you all the metrics along with this historical information, and you could get proactive notification alerts and fetch SLEs. The services monitored in Applications Manager for Amazon Web Services will be EC2 in the compute category, Lambda and EBS. In the containers, we support ECS and EKS. And in the database systems, RDS, DynamoDB. In the load balancing, it is going to be Elastic Load Balancer. And finally, and this is one of the most important aspect I thought of informing all the participants, if whatever cloud that you are choosing, right? The most important point is the billing factor. There are cases for an enterprise application workload 50 machines would be suffice. But in an unfortunate circumstance, if you have deployed like 80 machines, the remaining 30 virtual machines were underused and you were paying excess for those 30 machines. So you could, using the applications manager report functionality, you could find those machines and get notification about the pricing that you are spending on EC2 instances. Say, for example, per month budget allocated for EC2 instances spending is $100. And if the spending is going more than $100, then you can get a proactive notification from the tool saying that you have exceeded the allocated budget and you can take necessary actions to overcome this. So by this way, the billing parameters helps you. And when we talk about the Azure Services Monitoring Applications Manager, we discover Azure VMs, SQL Database, and Azure Kubernetes Services, AKS. So now let me give you an hands-on approach by taking you to the product GUI and show you a live demonstration on how you can discover. So once the tool is installed and if it is running successfully, you will have this page appearing right here. So let me log out and log in so that I can show from the very beginning to all the participants. So the moment I logged out, now let me quickly log in using my username admin. And I'm just typing my password here and click login. So the moment I click login, you could see this specific page. To get started with, all we have to do is just choose this cloud tab over here. And after choosing this cloud tab, we have the list of supported technologies, which I have previously explained. So you can choose the specific service of your choice. If, for example, choose AWS and you can get started with this. So here, this page will give you the complete step required to discover. It starts with uh, creating the access keys, which is if you're hurry, if you can just log into your Amazon Web Services portal, get the required keys, access key ID, and key, just paste it over here, okay, and key. And here there is an option called child discovery, which means if you wanted to add the Amazon monitor with its child components, then you could very well choose this option, discover and monitor. If you do not discover, then you could simply choose this option. And advanced settings, actions on deleted resources. By any way, due to your production workload requirements, if you are deleting any resources from from Amazon Web Services itself, then what this tool should take, what actions that we should take, whether we need to continuously alert you or stop alerting or delete that resource, whatever actions that the tool has to make, you could uh, input those options to the tool. And if you want to stop discovery of any of the specific services offered by Amazon, then you could choose this option called services to stop discovery and get started with this. And apart from this, few users have asked me a question. If I wanted to discover the Amazon, which is configured with an auto scaling feature. So for those case, we have an option handy in the settings option, performance polling. We have this tab called Amazon. So you could discover the Amazon using its instance ID or tag name. If you have enabled auto scaling feature in the EC2, then if you want alerts for the EC2 instances, you can enable or disable the same right here from this page and set health severity, whatever action that you need to take, and raise auto scaling alerts when EC2 instances are created, deleted, or both. So these options will be quite handy if you have configured auto scaling. So now, uh, once after discovery, let's see how we monitor the data and how we can configure the alerts. So once it is discovered, to get started with, all you have to do is choose monitors right here in the cloud apps category, choose Amazon, and all the services will be shown over here. So all you have to do is choose this option called overview, which will give you a complete basic information about the count, total EC2 instances deployed, number of application load balancers, count of network load balancers, number of Lambda functions deployed, number of Elastic Bean environments, and storage resources, total EBS volumes in use. If you have configured application integration, then you will be able to see the number of SQS queues along with its count. Okay, this is an basic information. And to dive deep into the EC2 instances, just choose this compute tab over here. And in this name category, it choose this specific instance uh, to get started with its specific performance metrics, CPU utilization, network traffic. Understanding the network traffic in a cloud-based instance is very much important because you have deployed 50 EC2 instances, and your application talks from one node to another. If you have configured multi-node application or a tier two application architecture, then there is a possibility of application making call from one node to another. And this call involves a significant amount of network consumption. Okay, network in and network out. So understanding this bytes per minute request is very much important. And production application workloads, disk IO operations. If there is a huge amount of disk IO ops, okay, due to a huge amount of traffic from the web server, all these operations will be routed to the hard disk where the residing data is present, which involves disk read ops and write ops. So if there's a peak in the disk read ops or write ops, then there is a possibility that uh, the application slowness would occur because there's no space to perform additional operations from the application, from the users to the client. There is no additional space or request to perform the operations because disk IO is always high. So setting up the right parameters, right alarms configuration for these metrics will definitely save your application workload hosted on cloud, which is a part of modernization and OS level metrics. And this is something more important that I would say because available memory on when you have deployed your applications on cloud, you wanted to see application specific with respect to the operative system. So available memory, committed bytes in use, so is what important, and disk utilization again, the partitions which is scheduled or which is created in the hard disk of that specific server in a cloud-based environment will be shown along with its total size, allocated size, and disk size. If there is any attached volumes, you could see its volume ID, snapshot ID, attached time, and if there is a termination happen, then you will be able to see delete on termination, false or true. So this is about the EC2 instances. So similarly, you get to see the high level metrics of containers by just choosing this containers tab. You could see all these containers listed, ECS or EKS clusters, and you get to see those metrics. And there are huge number of metrics like running tasks that you have configured, running EC2 task, and in fact running Fargate task, cluster services. Okay, so all this will be shown over here along with its cluster performance. This is one of the key metrics. Cluster performance, how well your cluster is performing, what is the CPU reservation percent, what is the CPU utilization and memory percent, CPU usage, and IO throughput and cluster network throughput. Okay, so now let me give you an hands-on approach on how you could discover the Azure components. So to get started with the Azure, all we have to do is just choose cloud over here. I'm choosing cloud. And right here, I'm choosing Azure. So the moment I choose Azure, basically we provide three different ways or three different options to the end users to discover your Azure components, Azure workloads. One is AD application and service principal. Second option is WAUth. And third option is Azure organizational account partial mode. So well, let's assume that we are going with the first option. Log into your Azure portal. Say I have logged into the Azure portal over here. So the first step that we need to do is uh, go to the specific subscription where you have created. Now choose the Azure Active Directory over here in the Azure portal. So once you choose the Azure Active Directory, in the left-hand side, you will find an option called App Registrations. The app registrations, you could find your app which is already created. If you have created a registration, that will be already appearing. If you haven't created a registration, then you could click new registration over here and get started with that. Since I have already created, I'm choosing this option, app registrations, choosing this. And right here, you could find your application client ID. So this is the client ID that you might have to use while discovery. And subscription ID, you can find it by choosing the subscriptions tab in the Azure. And this is your tenant ID, which you can copy it right here and use it. An application key is something very confidential to the administrators. They have to store it and keep it in a very confidential location. So once you have all this information, then you can quickly get started. Just paste all those information, click add monitor. And now after discovery, how the data looks like. So I'm quite interested to see how the data looks like after giving this information. So you could see Azure over here and the list of supported technologies. Uh, Virtual machines is what important. Most of the users have opted for virtual machines in the Azure. And you could see the virtual machine name. And by choosing this virtual machine name, you get to see the specific metrics which is relevant to the specific VM. Here you can see the CPU utilization percentage and CPU credits and CPU information, very specific to the CPU metrics, okay, which includes the IO wait time, idle time, and processor time, and memory information, and disk information, and network information, and configuration, which is in the Azure virtual machine. Hope this is clear. If you have any questions, please feel free to type in the webinar chat panel. We'll be happy to answer those again. Now let me go to the next topic for today, tracking the critical KPIs of your container orchestration platform. As a first step towards modernization or moving from service-oriented architecture to a microservices-based system is deploying, shifting the workloads to the containers, creating multiple images and deploy as a container. So why companies have shifted for containers, right? So if you have cloud, then why we are choosing with containers? Because of the primary aspect, fault tolerant capabilities of the containers. If there is any issue identified with a specific container named name A, so we could just simply uh, decommission that specific container and trigger a new container and immediately host the application with very less downtime, because you are not refactoring the entire application code or the entire application server. We are just rebuilding a part of your contain part of your application which is as which is present as an image in the container. Okay, for this specific reason, most companies have shifted to container based systems. You could in fact deploy Kubernetes to manage the containers, which it does very well because Kubernetes has a large community backed up by Google. It's an open source platform, and Kubernetes is available in multi for a hybrid systems itself because it is available on premise, it is available on cloud, it is available on multiple cloud. In fact, Azure Kubernetes, Amazon Kubernetes, so it is completely available in multiple load. It is just that when you shift your workload, enterprise workload, there is a case that huge number of uh, containers were deployed. That's where it becomes a challenge to manage, right? Huge number of container definitely becomes a challenge. So when we say huge number of containers, one container is responsible for a specific functionality. Another container is responsible for database related functionality. So any of the container has any CPU memory issue or network level issue, that is directly going to affect the issue, going to affect your users, whoever is accessing your application. So keeping a track on this containers is very much important. So let's see how we could get started with the container systems. And when we say when we talk about containers, OpenShift and Kubernetes plays a major role because you have an infrastructure, hosting infrastructure. On top of a hosting infra, you have an OpenShift cluster. On top of the cluster, we have depending nodes and parts and services deployed, which is used by your application workload, right? So the KPI is monitored in the OpenShift or Kubernetes, where nodes, the number of nodes that you have deployed, what is the current status, number of parts deployed, specific to the namespace, what is the current status, and the replica and deployments and services and deployments. Okay, and when we say or talk about Azure Kubernetes services, it is released on Azure Cloud exactly and easy to monitor with the Applications Manager hybrid platform cloud systems, and you could perform orchestration using the applications manager. If I say orchestration, you could automatically start a container, stop a container, or restart a container, and the users have a flexibility when to start and when not to start. And if an alarm, do this. Okay, so these kind of flexibility is available. So now, without much theoretical discussion, let's get into the product, and I'll show you a live demonstration over here. So let's take the Docker desktop, which I have deployed in my own machine. I have deployed one container which is hosting the SQL image, Microsoft SQL database, and this container is already running, and this container is used by the applications manager backend database. Okay, so this is quite simple. So now let's see how we can discover this container, which I'm showing. So let's start the activity. So we are going to start the activity of discovering the containers. So I'm choosing add monitor, and here new, add new. And this is the page where the list of supported technologies will be appearing. I'm just typing Docker and this image appears immediately. I'm choosing that Docker container, just giving a name for it, this something like Azure. Since this container is deployed in my own machine, I'm just choosing localhost, and it asks for port. So where's the port available? So basically, to get started with the container monitoring, as I was previously explaining, the data collection happen via REST API. So it is quite mandatory that you need to expose the Docker remote REST API should be enabled. The APIs should be enabled for remote access. Okay. So now that I am exposing the API in the port number 2375. I'm just using this number 2375 and I haven't created authentication just for demonstration purpose. And I'm choosing container discovery option. What options that we provide? Do not discover, discover and monitor. And discover and monitor specific containers based on regex. I'm going with the option second, which is discover and monitor all containers. So let's perform a test credential and it says passed. Next step is just click add. So if I click add, the it is done. The containers has been discovered, Docker containers. So how do I verify? By just choosing this monitor details. See, the moment I click monitor details, it says with a green tick saying that health is good, availability is fine. So now let's dive deep. How many containers that I have deployed? Yes, I can verify from the Docker desktop. I see that I have deployed just one and only container. Okay, what is the name? Festive Shamir. Yes, I could see that container, Festive Shamir, and the memory utilization percent. So this is quite handy when it is used in a large scale. Okay, that is hundreds of containers, thousands of uh, images being used by the containers. Okay, so now let's dive deep into the container metrics. So I'm clicking this container name that it is discovered, and immediately we can see that the CPU and memory usage has been already been populated, and other metrics have been started showing. So, and you could see the memory level information, that is the memory stats and memory paging. So since just now that I have discovered, it doesn't have graph. So once the sufficient data is available to plot graph, then you should be able to get the graph. Okay. So now let's see what if the same containers deployed on Azure, how it looks when it is discovered from Azure. So for that, I'm simply choosing this Azure and Kubernetes services. Okay. If we are using AKS and clicking the cluster name, and you could see the cluster information and namespace. We segregate the parts or the application load based on their namespace. The while you create your YAML file, docker.yaml or Kubernetes YAML file configuration file, the user or the administrators have a flexibility to create a namespace and associate that namespace with a specific parts, so that you could understand what is the performance metrics of your production load. What is the performance metrics of the disaster recovery? Okay, so by this way you could simply segregate and get started with those information, and you could see all those namespace has been discovered, cluster and CPU and memory details, and node details, and node count details as well. Top 5 nodes by use parts. What is the parts status? Use parts in cluster. What is the count? Part space. Okay. There are a lot of information that we need to discuss, but considering the time shortage, I will discuss one about the key metrics. If you're in need of a detailed demonstration, probably I request you to, you will be having a poll. Please express your interest in the polls. So node polls details, and most importantly, the node details. Top 5 nodes by memory details. These are the top 5 nodes which is consuming high memory usage. Okay. And these are the nodes and based on the parts and the free part and the node details. What exactly the node name is, what is the operating system deployed for that specific node, and Kubernetes version and all, and parts, and similar to the services. I was talking about creating the dependencies, right? So there's a functionality here called service map. By using the service map, you could find how one specific node is connected to another. So this is how it looks like in a small scale. And the persistent volumes. Okay, persistent volume ID details and services deployed on Kubernetes, Azure Kubernetes. What is the current status, the deployment status, and deployment availability? And for all the metrics, you have a complete flexibility to configure alarms. If I say configure alarms, we will discuss that now. So now that we have talked about discovering Amazon, Azure, containers. So now, how would you prevent your application workload from the performance related bottlenecks on cloud? The first step towards preventing your application workload is creating a right threshold. A right threshold is important. And in case if you want the tool to intelligently pick up the right threshold values for you, tool does it. How the tool does it for you using the AI ops based alarms. Okay. So I will give you a live example again for AI ops based alarms, how it works. And once the tool generates the alarm, the users have complete flexibility to perform orchestration, get emails kind of alerts, SMS notifications, and perform automations like SQL jobs, starting a container or starting a cloud-based instance, in fact. Okay, and pushing these alarms data to any other third-party system to perform any kind of automations completely possible. And analyze the application lag. So analyzing the application lag is what we have discussed in the part 2 series using the APM Insight agent functionality. If someone have missed the specific topic about analyzing the application lag specific to the code level insight, I would definitely recommend you to watch the part 2 recordings. And once the alarms were configured, what is the benefit outcome, right? So you will be able to prevent the server downtime, map the dependencies between the hybrid environment, that is cloud and non-cloud physical legacy systems, all this in one place. Prevent issues before it affects your users. Anticipate your resource usage. If I say anticipate, there is an inbuilt functionality called forecast and capacity planning reports. So what is the primary functionality of the forecast report? As of now, let's assume that, let me take you to the product GUI itself to explain that. Okay. So let's get into the applications manager. So I'll start with the enterprise capacity planning report. Now that let's assume you have deployed hundreds of containers, okay, and you want to see which container is overperforming, which container is not performing, who is idle. Pick the odd man out. Choose the capacity planning in the select server. Choose Docker. Right here, you have this option called undersized, oversized, and idle. By using this option, you can get started with these to pick out the specific values. So let me show you how it actually looks like. So for that, choose reports, and I'm choosing capacity planning. And for now, choosing Docker, choosing the idle one. So if I choose idle one, these containers were always idle. So I just easily picked up those containers in just single click. And if you ask a question on how application manager get this information, how come application manager can identify this specific containers were in idle state? And this is depending on just three parameters: CPU, memory, and disk. And the users, as a user, you have complete flexibility to configure this diagnosis. That is the rule name. You could see this rule name, and by just clicking this option called change settings used in diagnosis, you could find those information, and the criteria can be changed. And based on the criteria that you are defining, we pick out those machines or pick out those containers, pick out those cloud instances. Anything could be done. By this way, you are reducing the unwanted spendings on cloud, and make sure that you're complying with the security requirements. In fact, if you are having hundreds of servers, deploying a security changes on all those instances will be a challenge. So these kind of uh, challenges can be easily protected or overcome by using these kind of reports. So now let's go back on how we can set up proactive threshold or a AI ops based alarms, how it can be configured. So to configure an AI ops based alarms, all I have to do is just choose new threshold. In this new threshold profile, we have this option called adaptive. As the name itself suggests, it is quite adaptive to the systems. Okay, so this is primarily based on two different values, based on baseline values and custom expression. And if you have, let's assume, let me give you a scenario for a better understanding of the participants. So let's take a server A. Server A operates with the CPU utilization as 70%. Uh, Same time, Thursday, well, let's assume that the time is 8, 8 p.m. and the 8 p.m. server was operating with the CPU utilization of 40%. Okay, but now the server is operating with 90% or 42%. Definitely there is a spike. So this spike can be easily understandable by the tool if you define the baseline values. Okay, and you are training basically user, you are training the data model of the tool. Okay, it compares the current collected data with the data model that you have created. And how we are creating the data model is based on this baseline value or custom expression. And if we choose custom expression as a 30-day moving value average, it takes average of 30 days moving value average. Last week, by this time, the value was so much. And that value will be compared with the same time today, so that the threshold is not always static. During your non-production hour, the threshold itself, quite volatile in nature. So you get to see the alerts which requires immediate attention. And those alerts after your business hours, feel free. You get free, So these kind of flexibilities that it offers when you configure alarms. So now let me go back to the other functionality, which is called forecast reports. Forecast report is nothing but, as of now, let's assume that the disk utilization of the servers. If we choose forecast report of disk utilization of servers, it immediately picks out or creates a forecast of the disk utilization. Last month the disk was so much, and now the disk was so much, and by next 2 months the disk is expected to grow this much percentage. Month on month, how it grows. And how do we calculate this? By using a machine learning algorithm. And as a user, you have an option to toggle between the machine learning algorithm and with the normal algorithms. Machine learning algorithm is expected to give a high level of accuracy for the forecast reports. And immediately it fetch these reports and send this to the concerned server admins or the DevOps team to take necessary action before it impacts the user. So hope this point is clear. Let's discuss the final topic for today. So keeping a tab on the performance of your Microsoft applications. So similarly, we do discover the Microsoft components. If we talk about the supported technologies in the Microsoft specific way, we support Microsoft 365 monitoring. As a part of Microsoft 365, we support monitoring of the Exchange Online, SharePoint Online, and Microsoft Teams. I believe most of the users who are into the Microsoft house products will be definitely using the Teams. So, as a part of your organization compliance requirement, the admins wanted to understand how well this Teams been used, whether the Microsoft Teams is used for the official purpose or it is used for personal purpose for video chatting out with the friends. So these kind of compliance changes can be observed. So how do we do that? Because we monitor the chatting and calling details, the time or amount spent, application integration, and file sharing and storage and video conferencing. So services health, uh, activity, channel stats and details and the issues can be easily observed. And in fact, not only these details, the tool is capable of showing you service degradation issue. If there is a service degradation issue in the Microsoft side, we will be able to identify and notify you that there is a service degradation while sharing the files with the team's desktop application, so that your internal teams can be aware that there is something happening. We could hold on for some time. So almost we have come to the end of this session. A quick recap. So we have started this session with 7 R's of cloud application modernization. And as a part of the 7 R's, retiring the old applications, migrating the workload to the cloud, uh, refactoring applications. Okay, these components is what we have discussed. So as a part of this activity, you move to the AWS or Azure. When you move to AWS or Azure, you have the challenges like monitoring, maintaining, configuring the alarms, getting the reports in a multi-cloud based systems for your entire application portfolio. How this challenge can be easily observed or can be tackled using ManageEngine Applications Manager is what we have discussed. Gaining an insight into the containers based or OpenShift based environments when you have shifted to the DevOps based systems, and identifying the anomalies get inside your cloud, outside your cloud, and in fact in a specific on-premise data center, and configuring the right alarms using AI ops based approach, and focusing on the specific alerts which needs attention using the adaptive based thresholds. Finally, Microsoft Teams discovery. So thank you